So our next speaker is Dr. Chris Field. Dr. Field is the founding director of the Carnegie Institution for Science, the Department of Global Ecology. He's professor of biology and environmental earth system science at Stanford University, and the faculty director of Stanford's Jasper Ridge Biological Preserve, and that's a site that has been a very important site in global climate change research. Dr. Field's research emphasizes the impacts of climate change from the molecular to the global scale. His work includes major field experiments on responses of California grassland to multi-factor global change, integrative studies of the global carbon cycle, and assessments of impacts of climate change on agriculture. He was a coordinating lead author for the fourth assessment report of the IPCC, and in September 2008, he was elected co-chair of Working Group 2 of the IPCC for the current assessment, and is leading the second, the impact, Working Group 2 on the impacts on climate change impacts, adaptation, and vulnerability. Chris, thank you very much for being here.
You know, it's really exciting to have an opportunity to speak in a session that started out with really inspirational comments from Mayor Villaraigosa and Minister Jackson. I think where we are in the arc of the science and policy dimensions of climate change is a genuine sharp need for effective communication between the science end and the implementation end, and the visionary leadership of people like Mayor Villaraigosa and Administrator Jackson is really critical for advancing that. But smart, effective work on the part of the scientific community has to be a counterpoint. What I'd like to do is talk about the way the IPCC, the Intergovernmental Panel on Climate Change, tries to bring the science information to the point that it can be usefully addressed within the policy context. And I'm going to talk about 2.5 reports. I'm going to talk about the 2012 special report on the role of extremes, which are critically central to the whole issue of water resources, especially in California. I'll say a couple of things about the Working Group 1 report that Bill just told you about, and I will provide, IPCC has this kind of weird secrecy associated with the reports before release. So I can't tell you very much about the Working Group 2 report, but I will give a couple of hints. One of the things I will tell you is that's not the cover. We sampled hundreds of images as possible cover images, but one of the things that's striking about the climate adaptation agenda is that most climate adaptation work is people sitting around looking at PowerPoints, which is really boring, and it's really difficult to try and figure out how to communicate what the adaptation agenda looks like in a picture or two. And what I want to do is more or less present a word portrait. Let me just say a few more things about the Intergovernmental Panel on Climate Change. You've already heard a lot about it, and many of you are contributors. For those of you who have contributed either as authors or reviewers, thank you. You've made a big difference for the world. I think of the IPCC as a really unique partnership between the world's governments and the scientific community. The governments basically said, scientific community, if you'll follow our rules, we'll consider your assessments to be the definitive statement of what we know and what we don't know about the science of climate change. And the rules are complicated, and they involve lots and lots of steps, including for the summaries for policymakers, the source of many of the comments you saw from Bill, word by word consensus approval by all the world's governments. So that means that there's this incredibly high bar of recognition that whatever's in the SPM really has gone through a scrub and have been approved by every country word by word. I want to step back and just go through that one more time. If we're in a plenary approval session and I say warming in the climate system is unequivocal, I put that up on the whiteboard, and we don't leave that statement until you if you're Saudi Arabia, or you if you're India, or you if you're Angola, agree that that's an accurate assessment of what the science on the climate change says. And a lot of that, the reason that that's important is illustrated by this October 18th cover of The Economist. I should say, by the way, that none of the examples of how science went wrong came from Berkeley or from Stanford. But still, there are lots of examples of science being a process that is amazingly powerful in its ability to self-correct. It's not amazingly powerful in its ability to get things right the first time. And as a consequence, what you really need if you want to ingest science into the policy process, into support for good decisions, is ways for serious bodies to consider what science results have stood the test of time, which ones are useful for transfer to the policy process. And that's what's unique about the IPCC. There are other efforts that provide comparable kinds of value. The committees of the U.S. National Research Council, and at the state level, we've had some wonderful reports in California. But it's really important to have this vetting of science and ask, what are the things that are really standing the test of time, what's working? And I should say probably the best indicator of the effectiveness of the IPCC comes from the old adage that imitation is the sincerest form of flattery, and often the lower right-hand corner is a pseudoscience report from one of the skeptical organizations that is configured to look almost exactly like an IPCC report, showing how much they, I guess as well, respect the contributions of the IPCC. A lot of the work of the IPCC historically, this is kind of the arc of the certainty about a discernible human fingerprint on global temperatures. And you can see in the first report in 1990, they really thought it would be a decade or more until we knew. And then beginning in the 2001 report, the confidence in the contribution of human emissions greenhouse gases to global average temperatures has gone up and up until now. There's just the slightest sliver of a possibility that the majority of the changes we've seen have not been due to human actions. But when we think about the application of this to the policy process, we really need to transition away from this very robust scientific foundation that Bill described to thinking much more about this as a problem in managing risks. And that's really what I want to focus on today. We in the IPCC made our most serious investment in the broad challenge of risk management in the 2012 special report on managing the risks of extreme events and disasters to advance climate change adaptation, where we really explored not only the way that climate change contributes to changes in extremes, but the way those play out in risks of disasters, losses for societies, people, and ecosystems. Let me say just a few words about the general topic of risk. You know, for any kind of an outcome, temperature, precipitation, winds, there's some kind of a probability distribution. And as we move toward the right-hand end, especially of a temperature distribution, we typically have a set of consequences that are getting more and more serious as you go to higher and higher temperatures. So if you think about a probability of, let's say, high temperatures and plot the consequences on it, most generally it looks something like this. And in general, in terms of the impacts, it's useful to think about risk as something like a product between the probability and the consequence. So if you just take the product of these two curves, you get the green curve in the upper right panel there, and you can see that it's shifted to the right toward higher temperatures, and with lower probability events being the ones that are of greatest concern. And in general, that's what we see in the climate space, is that in order to make good decisions, we need to know not only about the most likely outcomes, but we need to know about the full range of possible outcomes, including relatively low probability, high consequence kinds of events. One of the implications of thinking of risk as this product of probability and consequence is that the motivation for action doesn't necessarily get stronger as you learn more. And in fact, if you look at an example like this, where the probability is smushed out potentially as a consequence of not understanding the background as well, what you see is with the same trajectory for consequence, the risk skyrockets as a consequence of having less confidence about the underlying science. So from a risk management perspective, actually, the situations we know the least about are in many cases the ones where we should be making the most serious investments. In the 2007 IPCC report, there was a conclusion that a changing climate leads to changes in extreme weather and climate events. And the way I think about it is that most of the impacts of climate, whether it's climate change or climate variability, really occur in the extremes. I think of weather and climate extremes as kind of the sharp end of the climate system, and whether the climate's changed or not, that's where things tend to break. Just to graphically present the 2007 conclusion, it's clear that it doesn't take a very big shift in the mean of something like this, this temperature distribution, this is a hypothetical temperature distribution, to lead to a big increase in the number of hot events and a big decrease in the number of cold events. And when we think about where we're experiencing climate impacts, whether they're in heat waves and hot days, whether they're in heavy precipitation or droughts, and those are the things that we've seen in the recent observations, it's clear that that's where the damages have piled up. And so I want to, in the rest of today's comments, kind of think through the issues about how the understanding of the kinds of changes we're observing really play out into the broad agenda of how we should be adapting to a changing climate. One of the things that surprised me the most when we started working on this special report on extremes, which, by the way, was a wonderful collaboration between Working Group 1 of the IPCC, the physical climate folks, and Working Group 2, the people who focus on impacts, adaptation, and vulnerability, was the understanding that disasters aren't natural things. Disasters are social constructs that really reflect the interaction between some kind of a triggering event, it could be a really severe event, it could be a modest event, and social conditions that are consistent with that penetrating into the scale of a disaster. And those social conditions involve vulnerability, the propensity to be harmed, a lack of resilience, and exposure, having assets that are in harm's way. In the IPCC report, the way we think about the overlap and the interaction between these three is that disaster risk really emerges from the overlap between weather and climate events, vulnerability and exposure. And when you think about the solution space, you could think about action on all three arms of that propeller. And of course, this is embedded in a much broader context. It's got forcing from both natural variability in the climate system and anthropogenic climate on the kinds of events that occur, and the issues of vulnerability and exposure are very deeply embedded in a social context, and especially a social context that has a big component of development going along with it. Of course, you can't understand the full set of interactions unless you look at the dynamics, and the dynamics include important feedback such that the realization of disaster risk often feeds back on development, typically in a very negative way, but both Mayor Villaraigosa and Administrator Jackson talked about ways that inspiration from the realization of disaster can be positive. And of course, as we think about development, we have an important control over greenhouse gas emissions that in the long run modulate the amount of anthropogenic climate change that we see, that we have to deal with, and that feeds back into this realization of disasters. It's important to understand that even though the science of climate change has advanced tremendously and the projections are getting better and better, there's still a substantial amount of uncertainty. And what I'm showing across the top is from the Working Group 1 report, the uncertainty due to climate model variability for end-of-century temperatures for a sometimes it's characterized as a middle-of-the-road scenario, but this is a very low-forcing scenario. And this, the variation between 25% of the models are lower than the results on the left-hand side, 25% are higher than the results on the right-hand side. This is a small amount of variability relative to the difference between a low emissions and a high emissions trajectory, but it's important. And so for these end-of-century numbers, these are from wintertime. You can see for California, we're looking at a warming between 1 and 2 C. on the lowest end of the variability and more than 3C on the highest end. Consequential. When you look at precipitation, these numbers get to be even more daunting. And this is exactly the same thing with precipitation shown in percent change from present with the areas that don't have the crosshatching being significant changes. And what you can see is that for some areas, if you contrast the 25% and 75% of the model space, the 25% has drying in South America and the 75% has a wetter South America. So when we think about making good decisions about climate change, it's not just reading out the prescription from the climate model and saying, okay, now we know what to do. Let me illustrate this even more clearly with another viewpoint on the precipitation perspective. So this is for RCP 8.5, the highest of the scenarios that's been considered in the most recent round of IPCC. I think of RCP 8.5 as very much business as usual. In fact, over the last 10 years or so since these scenarios were constructed, actual emissions have run slightly above RCP 8.5. 8.5 corresponds to the end of century radiative forcing in watts per square meter from the extra greenhouse gases. And in this representation, the brown colors are drying, the blue colors are wetter, and this map has something that you haven't seen in previous maps, which is gray areas. Gray areas are ones where the large majority of the climate models say we will have changes in precipitation outside the background variability. We'll have significant changes in precipitation, but the models don't agree on the sign. Some say significant increases, some say significant decreases. The classic problem in risk management. We don't know whether the right answer is to build a dam or to tear down a dam, but what we know is that we need to put a lot more emphasis on finding ways to have a sustainably crafted water system and one that can deal with a range of variability in the future. And I think if there's a single important lesson in the adaptation area, it's that acknowledging this kind of variability is going to be really important. Even where the climate changes are known with a high level of certainty, by the time they penetrate into societal changes, it's the variability that becomes key. You know, throughout the history of climate science, there's often been this sense that there was a tension between investments in adaptation, coping with the climate changes that can't be avoided, and investments in mitigation, reducing the amount of climate change that occurs and protecting ecosystems and societies. I think we've now finally advanced beyond that, and we've advanced beyond it for two critical reasons. One reason is we understand that the kinds of investments that can advance both climate adaptation and mitigation typically do occur together and in fact work better when they occur together. But it's also important to recognize that they play out in different parts of the coming decades. And in particular, if you look at, this is the contrast between the temperature trajectory for the highest and lowest scenarios that were explored by the IPCC. And you can see there's dramatic changes in temperature at the end of the century. But if you look out in the period a little bit before 2050, I'll draw a band over the 2030 to 2040 time period, you really see something where the scenarios haven't diverged much. Lots of warming, a much different world, but you need to think about this as an era of near-term committed climate changes. I like to think of it as an era of climate responsibility where we just have to acknowledge that we have a world that's changed dramatically. This is a period where investments in mitigation are going to make a big difference in future decades, but they haven't yet begun to make a difference. And the lowest and the highest scenarios have essentially the same temperature outcomes during this period. Then, of course, by the time we get to the end of the century, we're looking at an era of climate options where the consequences of being in the blue world and the red world there are dramatically different, and I'll come back to that at the end. But what I really want to do over the next couple of minutes is talk about a map, and this is a map of what I consider to be the solution space. I showed you in the overlap between events, vulnerability, and exposure what you might think of as the map of the problem space. And we now have the opportunity to say, okay, what do we need to do in order to fix it? And the solution space has a bunch of components, and they interact in diverse and complicated ways. But I think we're finally getting our arms around the kinds of investments that are practical. We're far from getting our arms politically around the kinds, the commitment to make the full range of investments that need to be made. Before talking about the details of the solution space, I want to say just a couple more things about the way that climate extremes play out in terms of being converted to disasters. Sometimes you get a huge event, a gigantic heat wave or a gigantic drought that leads to a disaster. But often disasters play out as a consequence of a relatively modest climate event, or sometimes a series of modest events that just hit at the wrong time or the wrong place, or a society that's fundamentally unprepared. Here's one example that was played out in the IPCC special report, and it's a really important reminder that investments in building resilient communities can make a huge contribution to protection from extreme events. It's also important to understand that the impacts of climate change play out in very different ways in different parts of the world. You know, we tend to think about hotspots of vulnerability where people are poor or lack good infrastructure. But when I look across the global landscape of impacts, the main thing I see is that every place is vulnerable, but the kind of impacts are different. What you see is gigantic economic losses in the world's developed countries, and you see existential losses in developing countries. And the staggering reality is that in the past 40 years or so, 95% of the fatalities that are associated with climate-related events have come in developing regions. And recognizing that there's no single metric that characterizes vulnerability, and that the kinds of solutions that are required are very different depending on what infrastructure is a really key starting point. So as a consequence, I want to talk about how you think about dealing with the adaptation agenda, mainly as an exercise in finding the right starting point, opening out the agenda, and then figuring out what can be done. And here's one example that we've already heard about, the massive loss of life that was associated with the 2003 heat wave in Central Europe. And we know a lot about the climate occurrence, the extent to which climate change amplified the probability of that event. We know that we're headed for a future with much higher frequency of this, but we also know there are a whole bunch of factors that contribute to risk, and that it wasn't everybody who suffered an equal risk of extreme outcomes in this event. And we also know that there are a whole bunch of kinds of solutions that can be put in place on the right side of this image that can really dramatically decrease the risk of loss of life during this kind of event. And those played out to a very positive consequence in the 2005 heat wave in Europe, which was actually very similar to the 2003 event. So let me run through some elements of this map of the solution space that reflect the kind of consolidated experience of the global community as reflected in the 2012 IPCC report. The first key finding is that there really are no single bullet solutions, silver bullet solutions that solve the climate adaptation problem. The things that work best are investing in a portfolio of actions, recognizing there are different vulnerabilities in different places and different needs and different success expectations from different kinds of investments. When we're thinking about extreme events, it's important to have effective communication, to reduce the risk of extremes, and then to be able to transfer the risk and respond to the risk as it occurs. Second, it's really important to recognize that we face a world with lots of different kinds of risks. Some are related to climate change, some are related to human security, some are related to the global economic system, and that investments in adaptation that address more than one hazard at a time are almost always better in terms of cost-benefit ratio than investments that only focus on a single kind of risk. A third key conclusion is that there's no single scale of actors. We heard a lot about what we can hope to see accomplished in cities, and there are wonderful opportunities, and there's been wonderful leadership at the scale of cities. But there are other kinds of decisions that work best at the scale of a family or a firm, other kinds of decisions that work best at the scale of a national government or an international organization. And that trying to solve the entire problem with investments at one level only is much less efficient than recognizing the benefits of linking from local to global scales. And then finally, it's important to recognize when we think about the adaptation agenda, even though there's a lot we know, there's a lot we don't know, and that effective decision-making really requires an iterative approach where we take steps, learn from those steps, go back to the drawing board, and then take next steps. You know, the way I think about the adaptation most broadly is that we're trying to address two big parts of the time and space scale. We're trying to find steps that decrease short-term risk while building long-term resilience. And at least for me, the thing that is most critical about that is to recognize that there are three parts of the global development agenda that we typically think of as three distinct things that are really different aspects of one thing. Disaster risk reduction, climate change adaptation, and sustainable development are all really different sides of the same coin, and until we can merge those, we're not going to make the kind of smart decisions that the world needs. Finally, I want to leave you with what's probably the most important part of the adaptation agenda, and it's not about adaptation. If we go back to the map of the problem space, I had a subtle arrow across the bottom here associated with greenhouse gas emissions. And I want to leave you with the image of the global temperature map at the end of the century for an aggressive mitigation scenario and a business as usual scenario. The top picture is going to take heroic efforts in order to produce a world that warms only 1.5 to 2 C. Business as usual results in a world where the global average temperature has increased about just a smidgen less than 4 C in these simulations, but with almost all the land areas increasing by much more than that, and the high latitudes increasing by unimaginable 8, 9, 10, 11 C. We can't solve the adaptation challenge in the bottom world. Thanks very much. Can you just sit over here?